morning student. Welcome to VVPS e-learning class. This is your science class and we have discussed chapter 10 fun with magnets. In the previous video we have discussed that how natural magnets are discovered. We have seen here the natural magnets are discovered with a chemical compound which is known as magnetite, which has an attracting properties of iron filings. Now today we have discussed the some other properties of magnet through an activity 4 and activity 3. Just let us discuss activity 3. Activity 3. Rub a magnet in the sand or a soil. Pull out the magnet. There are some particles of sand or soil sticking to the magnet. You all know sand and soil particles are not sticking to the magnet, because if you are seeing my previous video, you have seen that magnet only and only attract irony particle. Now gently shake the magnet to remove the particles of sand or soil. Are some particles are still sticking to it? Let us see. These might be small pieces of iron or iron filings picked up from the soil. So through such an activity we can find out whether the soil or sand from a given place contains particles that have iron. And these irony particle, as you have seen in these three figures, these are the three pictures of the bar magnet, and you all know this contains two poles, north pole and south pole. What this picture indicate, you have seen the irony particles are highly sticking to the ends of the magnet, not else anywhere. Does the magnet with iron filing sticking to it look like any one those shown in figure 10.6? And we have seen that these iron filings are sticking at the poles of the magnet. Now poles of the magnet, we observe that iron filings, if they are present, stick to a magnet rubbed in the soil. Did you observe anything special about the way they stick to the magnet? Yes, it is very much special. And what speciality this sticking of the iron filings we have discussed through an activity 4. Let us see this activity 4. As we have seen in the activity 3 that maximum iron particles are sticking to the poles of the magnet. Just look at this activity 4. For activity 4, spread some iron filings on a sheet of paper. Now place a bar magnet on this sheet. What do you observe? Do the iron filings stick all over the magnet? In this diagram you have seen clearly the iron filings are not sticking all over the magnet. You have seen, like in activity 3, maximum iron filings are sticking to the ends of the magnet, and these ends are indicating the poles of the magnet. And in a bar magnet, this end is known as north pole and that is known as south pole. And do you observe that more iron particles filings get attracted in some parts of the magnet than others? Remove the iron filings sticking to the magnet and repeat the activity. As we have just repeating the activity by removing the iron filings again and again, what do you observe? Do you observe any change in the pattern in which iron filings get attracted by different parts of the magnet? So we can do this activity using pins or iron nails in place of iron filings. If iron filings are not present, then we can repeat this activity with the help of using pins and also with the magnet of different shape. Likewise, in place of bar magnet, we can take horseshoe shaped magnet or cylindrical magnet. The result will remain the same. So as we draw a diagram over this, then you have seen that maximum iron filings get stick on the poles of the magnet, and these diagrams are very much similar as we have changes the shape of the different kinds of magnets also. So we find that iron filings are attracted more towards the region close to the ends of a bar magnet, that is, poles of a magnet are said to be near this end. Why these iron filings or pins are sticking these ends? Because they are referred to poles of a magnet. Try and bring few magnets of different shape to the classroom and check for the location of the poles in these magnets using iron filings. As we have taken so many different kinds of magnet in the classroom, the result will remain the same, and we can see this result of the activity that maximum iron filings are get stick towards the poles of the magnet. Now you have seen in that magnet that there are how many poles are there present? There are two kinds of poles, that is north pole and south pole. And in the same kind of pole you have experienced a force, that is force of repulsion, and different kinds of pole you have experienced a different kinds the force, that is force of attraction. Just let us see if the poles of a magnet are the same. If the poles of a magnet are same, we have discussed a force that is known as repulsion or repulsive force. And if their poles are different, they have experienced a force that is known as attraction or attractive forces.